Hi guys! Welcome back to another virtual summer in the garden video. I'm Miss Nicole and this is Miss Kelsey.
Hey guys.
This week is Fun in the Sun. We're going to talk all about sunlight. If you remember last week we talked about adaptations. Well, sunlight is a specific adaptation.
So sunlight is especially important to us down here in the garden because it's one of the main ingredients for photosynthesis. So plants use the sunlight in order to photosynthesize to make their own energy so that they can grow and survive. For animals, just like us, we need those plants to survive because they're the base of our food chain. So we need to eat those plants in order to grow and survive ourselves. This week, we're going to be talking about a few different things about sunlight. One of them is sun protection. So you want to make sure that whenever you're in the sun, especially down here in the Florida Keys, that you're wearing sunscreen. And another consideration that goes into it is our coral reefs that we have down here. So we want to look for sunscreen that is reef safe, so meaning that it has certain mineral ingredients and excludes some chemicals that are harmful to our reefs. So this week we're going to be talking about UV and infrared radiation. We're going to be measuring their wavelengths. And then we're also going to be talking about specific sunlight adaptations for different plants that we have down here.
And today we're going to look at two ecosystems, pineland and hammock. We're going to compare and contrast both. And then we're also going to learn how to make a solar still. So thanks for joining us. Stay tuned. The first ecosystem we're going to discuss is pine rocklands, also known as pinelands. Now pinelands are typically higher above, very dry. The vegetation is usually very low, and it's made of limestone with a thin layer of soil. It's also usually a very open space with little shade. Some common plants in the pineland ecosystem are a cootie, which is a pretty cool plant because this has been around since prehistoric time. And then we also have the silver palm, which as it blows in the wind, you can tell why it has the name silver, because the bottom of the leaves almost look silver. These two plants are in the pineland ecosystem because, as you can see, they have a thin layer of soil and they have big, wide leaves to soak up a lot of sunlight. And here in the courtyard, we have very little shade in this open area, so these plants can thrive with getting their sunlight, like the pineland area. And another fun fact is key deer like the pineland area. Can you think of a spot here in the Florida Keys where we see key deer? Big Pine. So Big Pine Key is a pineland ecosystem. Our next ecosystem we're going to discuss is hardwood tropical hammock, also known as a hammock ecosystem. Now hammock ecosystems are typically higher ground, and unlike pinelands, they are moist. So here we have a pond. Also hammocks have limestone rocks. So here we can see, and the limestone rocks form something called a solution hole. And when it rains a lot, it eats away at the rock, creating these little pockets where rain can hold. So another reason our hammock is wet. Hammocks also have lots of leaves and branches that kind of fold over and interlap all over each other high up, which creates a canopy. The canopy blocks some of the sunlight from coming down, so we get lots of shade in our hammock ecosystem. In the hammock ecosystem, we have a couple examples here. We have the Buccaneer Palm, which got its name because of its horizontal stripes resembling what pirates used to wear. This palm is also very endangered, and it typically lives in the hammock ecosystem because it gets lots of shade here. And most of you are also familiar with the gumbo limbo trees, also known as the tourist tree for its peeling red bark. We have one over here, and then we also have some over here, which are also along with the Buccaneer Palm inside of the hammock ecosystem.
Hey guys, so for our activity today, we're going to be making our own solar still. So this week is all about sunlight. Earlier, we talked a little bit about how sunlight is important to plants because the plants need the energy from the sun in order to photosynthesize and to make their own food. Well, another thing that sunlight is important for is the water cycle. So the sun heats up water and causes it to evaporate. That water that evaporates ends up as clouds that we can see up in the sky and contributes to our water cycle. So today, we're going to be turning salt water into fresh water using the sun's energy. So in order to build our solar still, some things that we need are plastic wrap, scissors, some small rocks, a smaller plastic cup that's clear, a Sharpie, a larger clear container, some duct tape, and salt water. So I collected this salt water from across the street in a canal. You could also make your own salt water at home. So just using tap water and some table salt and just kind of stirring it in there really well. So to begin, we're actually going to be testing our salt water to see how salty it is. At the end of the week, after this experiment is complete, we're going to come back and test the fresh water that we made to see the difference in the two. So the tool that I'm going to be using in order to test our salt water is called a hydrometer. So what this does is basically measure the density of the salt water. So whenever there is extra salt particles in our water, the water becomes more dense. So whenever I fill this up with water, this arrow right here will float up. The farther up that it floats, the more dense that water is and the more salty that it is. So first thing I'm going to do is fill this up with salt water. Now I'm going to hold this fairly still for a little while, let the arrow bounce around a little bit, and then we're going to read the number on the outside here. So that's measuring salinity in parts per thousand. Now down here we have very salty water because we have very shallow water and it's very warm here all year long. So it looks like my arrow is kind of settling on the number 40 right here. So that means our salt water is about 40 parts per thousand. So the first step in making our own solar still, we're going to fill our little container up just a little bit with some of this salt water. All right, so I've got a little bit of salt water down here. I'm going to take my Sharpie and I'm going to mark the water line so that later when I come back and look, I can see just how much water has evaporated. Mark it right about here. Our next step is to put in our cup that's going to collect all of our fresh water. So our smaller cup right here, I'm going to fill it with some of those rocks in order to weight it down so that it'll stay in the middle. And then I'm just going to place it right in the middle of our container here. So after that's complete, we're going to take some of this plastic wrap or cling wrap. So you just want to get a nice sheet. Down. I'm going to use my scissors to cut off a piece here. And then you want to stretch it out all the way over the top here. I'm then going to take some pieces of duct tape that I've already cut off to secure the edges and make sure it's extra tight. All right, so now that we've got our plastic wrap lid in place, the last step, you're just gonna take a few small rocks or anything that has a little bit of weight to it, and you're gonna place them right on top of our cup that's in the center here. Then you have your solar still ready to go. The last step is just to place it in a sunny area, and we're just gonna wait. We're gonna let the sun evaporate that water and turn it into fresh water. So what's happening here, the salt water down here will evaporate. It's going to kind of collect on the plastic wrap here on the top, and it'll roll down and drop off in the center here. So tune back in on Friday, and we're gonna test our fresh water and see if it works.